So now we're going to parse a little bit. And what do we have up there? It's called the grammar. And what this blue S means is I have some sentence that I want to prove. Blue for prove. And how do I parse it? And the yellow means I have some sentence I want to assure myself is true. Some oracles assuring me. And what does the arrow mean? It means that we can get the thing on the left by something on the right, right? And then what are these ors? Well, a string S is either a for all statement, an exist statement, it's an imply statement, it's an and statement, it's an or statement, or it's some sort of base case, right? And then all the colors are given to you by, if it's yellow, the oracle is providing. If it's blue, the prover is providing. If it's red, the adversary is providing, right? All right, so and then at the bottom, what's a term? This is a good thing to know, the type of stuff, right? If you're doing computer science, you want to know this variable represents an integer, right? Well, these T's represent terms. And what does a term represent? It represents an object, right? So if your universe is of boys and girls, then all your T's are either are boys and girls, right? If your universe are integers, then all your T's are integers, right? And so these are functions from terms to terms, right? Objects to objects. Well, relations return true, false, right? So let's go through and see how we might parse this, right? We can say, okay, this is blue. We want to prove it. We want to say, what's at the top level of the parse tree, right? Anybody see what's the last thing that happens, right? Is the implies, right? So we go to the implies thing, and here we have the way it's parsed out is the way you prove this is you have the oracle assure you of this, and then you prove this, right? Everybody kind of get that? Right, and then, right, the oracle assures you of this, I prove this. Right, now, this here is something I want to prove. So how do I parse? What's at the top here? Anybody know what's at the top here? What happens last is the for all, right? The brackets go inside. So you say, well, what is it? It's a for all. And so here I've got it parsed out as, right? The adversary gives me a value of B, and then I prove the statement, right? Versus this exists, I construct a G, and then I prove the statement, right? Does that make sense? Are you following this? Yeah. Versus over here, the oracle constructs the G, and over here, the prover provides the B, right? Does that make sense? All right. Oh, and this is kind of those arrows. This is my early version of the arrows. She gives you, when it exists, the oracle gives you something which helps you construct, right? And here, when I receive something from the adversary, I often give it to my oracle to receive the for all, right? So there's traveling of information across this tree, right? Does that make sense? So, all right. Now, I spent so much time taking all my examples and making these big trees, and I think it was overwhelming. So I decided to back off. And I mean, you can parse it out this far if you need to sometimes, but sometimes it's easy enough just to leave it here because this is a game and this is a game, and we just play the games at that level. All right, so you can decide how far you want to parse it, but you need to know how to parse somewhat. And now, this is another thing I think people are missing. If I tell you that we're working over the reals, right, then a sentence is either true or false. If it's not true, then you can prove it's false over the reals, right? It's like, does 3 plus x equals 7? Well, I don't know. If I plug in a 4, now I'm working over 4. And so I know it's true. If I was working over 2, I would know it's false. If I don't know what the model is, then it's only valid if it's true over every model, right? And this is clearly not true over every model. Some models it's true, some models it's false, right? So the negation, this isn't a tautology, but the negation isn't a tautology either, right? People get that? All right, so here, what are we doing? I'm trying to prove that this is a tautology. So it's over a worst case model. So you can assume kind of, where are we doing it here? All right, so I guess oh, there it is up there. It went up there. Okay, see, I made them, I was looking for something red, but I made the models in green for some reason. All right, so here it's implied for every model we want this to be true, right? So when you parse it, it starts off by saying the adversary gives you an arbitrary model, right? Does that make sense? Are people good? He is such a good nodder. Why can't you nod like him? You know, you do this, right? Good, good. I know you can do it. I know you can do it, right? Right. So here's how the game goes, right? Here we just say, I need to prove this. So how do I prove it? Well, I get an arbitrary boy. Then I construct a girl, right? And then I have to prove that, right? That's the game I play. And what's the game over here? She assures that there exists one, so she constructs one, right? And then I provide a boy and she proves there's love, right? Those are the games. And you merge the games together so you get a proof, right? People see that? All right, so sprinkled through the next few sections, we'll bring in parse examples. All right, we're not going to do them all at the beginning because you might not remember them. But here's a parse example. All right, what's at the top? It's the implies, right? This stuff implies that stuff, right? And now, how do you do an and? Well, if I want to prove an and, I have to prove both, right? And if the oracle is assuring me of an and, then she assures me of both. And sometimes it's nice to give them names. Oracle A, Oracle B, Oracle 1, Oracle 2, right? So when you say Oracle 1 tells me, then we know where she's coming from, right? Everybody good? All right, here's the or one, and ors are harder, right? So you parse it there. Now I have to prove the or, so I get to choose which one to prove, right? Now that's okay, but here the oracle's assuring me of an or, so she gets to know which one to prove, right? Now, so if I've proven an or, remember purple table. I've been a little frustrated because I've been saying this to people. I say, purple table, or, how do you do it? If you know it's true, how do you use it? And people always say select or, right? If you know one of them's false, then the other's true. Select or is great, but it's only useful if you know one of them's false, right? And then I say, no, we don't know which one's false. So how do you do or? Proof by cases, right? And in fact, this brilliant man here showed me a question last class, and at first I didn't know how to do it, and then it came down to cases, right? And so when I was laying in bed last night, I was thinking, well, how do I do it with the game? And I thought, oh, it's impossible. Did we come up with a problem where it's impossible to do it by the game? And no, you need the cases, and you bring the cases in, and it's beautiful. And I already have too many slides, so I'm resistant, but I'm thinking about making more slides on it because it really is a nice example. All right. In fact, I had come up with a formal proof that was really ugly. And then when I came up with this game method, it then led to a much nicer formal proof. So, all right. So anyway, right, the problem here is that the prover doesn't know which one the oracle is going to choose, right? So we do. Suppose the oracle assures me of the first one, right? Then, right? All right, she assures me of the or, so maybe she assures me of the first one, in which case, in that case, I go for C, right? Because I get to choose which one to go for. Maybe if I know A, I can get C, right? And then, maybe when she gives me B, then maybe I go for D, right? Does that make sense? And that's kind of what we did. That we did this in that hard example that everybody died in last class, right? Everybody got that?